Welcome back. This time we're going to make use of a specific question to see how we move from Kc expression, to see how we move from moles given to us, reacting, getting into equilibrium, finding equilibrium concentrations, and from equilibrium concentrations into a Kc value. How do we do that? Let's have a look. You're given 6 moles of nitrogen and 10 mole of hydrogen reacting in a 5 cubic decimeter volume, and you are told 3 moles of ammonia formed at equilibrium, and the equilibrium is reached at that temperature value there. First, let's give the ratio. From the balanced equation, we know that this will be 1 mole is to 3 moles to produce 2 moles. That is the molar ratio. Initially, we are told we're starting with what? Let's have a look. 6 moles and 10 moles. So 6 moles there, nitrogen, 10 moles hydrogen, and there was nothing there. It was still at the beginning. And we are told 3 moles are formed at equilibrium of ammonia. Okay? So 3 moles ammonia formed at equilibrium. It means here if 3 moles was formed at equilibrium, which is there, it will mean that plus 3 there were formed. Now if this one here is according to the molar ratio that we have here, this one is always twice the number of moles of nitrogen that is going to be used up. Now this would mean that if 3 is formed, half of 3 must be the number of moles of nitrogen that has been used up. And what is that half of 3 is 1.5. So I would say minus because it has been used up. This one, hydrogen, is always 3 times what the number of moles of nitrogen is in that reaction. So it will be 3 times 1.5. So it will be minus 4.5. Okay, now equilibrium concentration equilibrium moles nitrogen will be 6 minus 1.5, which will be 4.5. This one here, it will be 10 minus 4.5 is going to be what? 5.5 for hydrogen. Okay, now from this I can actually find my equilibrium concentrations. This is 4.5 for nitrogen. Okay, just allow me to do it this way here, and then it's 5.5 at equilibrium for hydrogen, and it's 3 for NH3 ammonia. So I can find equilibrium concentrations here because concentration is number of moles over volume. Okay, so for nitrogen it's 4.5 divided by 5 because this is happening inside a volume of 5 cubic decimeters. So this one here for hydrogen is going to be 5.5 divided by 5. This one for ammonia is going to be 3 divided by 5 as well. This one gives me, allow me to use this space here, is going to be 0.9 mole per cubic decimeter. That's for nitrogen. And this one is going to be 1.1 mole per cubic decimeter, and this is going to be 0.6 mole per cubic decimeter. Now Kc for this one will be equal to concentration of NH3 to the power 2 divided by concentration of N2 to the power 1 times concentration of H2 to the power 3. So you can substitute into that and say your Kc is what? NH3 is 0.6 to the power 2 divided by 0.9 to the power 1 times for hydrogen is 0.6 to the power 3. And then you work that out and you get your answer. That's where I have to end it. That's how far I could go in my time here. See you in the next section.